Hi, hello everyone. So last time we created this kind of triangle, and this time actually we're going to be working with textures. And the idea of this video is basically to create a quad and then just to texture it, so that we know how to load the textures, and then that really gets us going somewhere towards our game. And for this, I'm using this free texture. It's probably good texture because it also shows us here, for example, what does it show us? It shows us screen coordinates here, right? We have 0, 1, 1, and you're going to notice the texture coordinates are actually going from 0, 0 to 1, 1, instead of like we had before, minus 1, 1, 1, minus 1. No, this was positive, this was negative. Anyway, this was positive, this was negative. That's fine. That's fine, yeah. Anyway, so how do we do that actually? Uh, it's fairly easy. Just give me a second. I need to prepare myself here. So uh, last time I mentioned that we can draw either point, line, or triangle as a primitive. And since here we already have a triangle, right? And it's made of vertices. Let's say this is V1, V2, V3. So how do we draw a quad? Well, basically we just add another triangle, and this might be V4. It will have the same coordinates, right? This will be the same. And then we might have V5, and then we might have V6. And this V6 is going to have same coordinates as V3, but we still need to fill it. And then we just fill it with colors. So this might be green again, this might be blue, red, whatever. It doesn't matter. So let's actually get started with this, and for this we're going to go to main ts, and then we're just going to start the filling out the details. Maybe I should zoom in a bit. Hopefully that's better, or I can do this actually. Okay, let's do this. And then no, this first way was way better because we can we can code and show at the same time. So where were you? Second here. Let's see. We were here. I'm still trying to get used to Mac, so sorry about that. We are here, and then we had this position buffer, right, which defined these vertices here. And then we can just say this was maybe left bottom, this one was left top, and then we had right bottom. And now we're just going to copy them. Let's see. How should we do it? Let's start from left top again. And 0.5, 0.5, left top, then we need right top, and then we need right bottom. Exactly. If I save it, nothing happens. That's because we also need to fill out the colors. We can just shamelessly copy paste this to save time. Nothing happens yet because if you go to draw method, this argument right here, 3, it's standing for number of vertices. We had 3 previously. Now for second triangle, we need to copy this again, and then we have also this one here somewhere. So therefore we just pass 6, and then we have our triangle, other. And this is basically how you do the meshing. Let's see here. This. So how does this work? So for example, if you had a cube here, for example, oops, sorry. If you wanted to draw a cube, right, let's say like this. So how does it work? Well, you just need to define more triangles. So this would be one triangle, this would be another, right? Because that's the primitives that we can draw. So all the models are just made of a bunch of triangles. All right, let's see. Now that we have this, we can actually start with our texture coordinates. Let's just change colors here. So 1, 1, 1, because we're going to need all of those to be 1. And if I just do this bunch of times, this, and this, and then I save, and we have a white rectangle. That's perfect, and then we can start from here. So let's start. For texture coordinates, we need to start from our, well, let's just start from the vertex shader. And then I'll just remove this. So next thing that we're going to need is layout location. I'm going to use one for texture coordinates just because I find it a bit well, I just prefer it here for some reason. And we can just change color to location 2, and then we don't need to do anything in vertex shader with them. We're just going to pass them to fragment shader. So this texture coordinates attributes, and then let's just say vtext coords is a text coords. And that's everything we need to do with shader. So this is broken because we changed this layout location. But let's go to fragment shader again. And here we're now taking in also vtext coords. And then we need to actually get the texture, and we did do this with the same project. So these represents the texture coordinates, right? If we imagine second, if we imagine that right, we have this texture here, right? This is the texture itself. But you don't have to draw the entire texture. You can always just draw the part of texture, right? Maybe we just want to draw this part or this part, or maybe just left half, right? So we do this via texture coordinates here, and the texture object, it just represents this whole texture, this sample thing. It just represents the whole texture which is loaded into WebGL. All right, so let's see then, and how do we actually draw it? We just use method texture, which takes, as you can see, sample 2D and then vector2 coordinates. So let's say just say you texture and then we text coords. And then we can just multiply it with color. We don't have to. We could just draw the texture and that would be fine, but we can also multiply it with color, and we're going to play with it a bit later. So just that you see some possibilities that we can do. And now let's start with our texture. So let's see. We define it here. And then let's say texture coordinates. Let's use array 0, 0. That's fine. Let's just add left bottom, left top, right bottom. That's fine. Left top, fine. Right bottom, fine. We're done here. And then we just need to actually create array bar for texture coordinates. Let's just call it const text buffer. And as always, we need to describe it. This GL vertex attrib pointer, and then 1, 2, because it's a vector 2, it just has x and y, and this we'll leave it as it is. And then same here. And as you remember, here we changed color location to location 2, so let's do this here as well, right? We're just going to change the color buffer to 2, and if I save it, nothing will happen because we still need to load our texture to WebGL. And how do we load a texture? We can just say const texture, and we're going to create a method for this. Let's say load texture, and then we need to pass our texture path to it, and this is this texture mapping test image. I have placed it here. You can as well place it in. I place it in folder assets, and then it's just this texture that I will provide link to in description of the video, but you can also just download it from GitHub or use any other texture. It doesn't have to be this one. And this is just example, and it was called, I'm just going to copy this name because I'm lazy for typing, assets texture, and it was, mine was of type JPEG. If you use some other type, you can edit here, and then just declare method, and here is our method. It's a private method that's going to create WebGL texture. All right, just to see something, and let's make this global. Private texture. Let's just change this to global, and then let's go back to load texture. We can get rid of this. Now let's start with loading our texture. Create texture, then we have to bind it with every resource. Once you operate on it, you have to bind it, and then we can just return texture. And now nothing is going to happen because we still haven't moved any data to a texture. And as you can see, we didn't do anything with this URL string. So now this is the case, right? Because our texture is resource that needs to be loaded. It might do that a bit later, right? So if I do this const image is new image, we will have this on load. I'll explain it in a second, and then we provide source. So the thing is, once you set this URI, the code is going to continue to execute, but the image is going to be loaded later, and then on load will be called, and the texture will be loaded here, right? So we're going to need to fill the data here, and so for now I'm just going to copy this because we might have other texture. We don't know when this is going to be resolved, and then we can just fill up the data. All right, and here I'll just break this a bit. Let's break these arguments here so that it's a bit more readable, and then I'm going to explain them. So if I save, still nothing happens. Let's just do this as well. Generate mipmap. Nothing happens because it's loaded asynchronously. So we're going to get back to this. Let's just go to our draw method and do this. Sorry, not this window request. And if I save it now, it shows. And I'm going to explain this one quickly before we return to texture. That's because previously we have drawn everything, but texture was still not loaded. But when we request animation frame, we essentially start game loop, right? And this request animation frame is going to call draw 60 times per second. So we get to this, and then we just start from the beginning. So it essentially does this. What does it do? Right? It gets here, then loops back here, right? And then it goes do, and then it goes back here, and so this is how it works. It just loops this code over and over again. We're going to be dealing with this a little bit later once we start with the animation and game programming, but for now let's just place it here so that we can see our texture, and this is really good. So just to explain these arguments here, let's get rid of this. I don't need this. And here. So we had this argument that actually has to do with the bitmaps. And the zero argument says use our original texture, and texture is upside down. I'm going to get to it. But essentially what Mipmap is, as you can imagine, we might have a texture that's this big, we might have this big, we might have even bigger one, this might be further away, some might be closer, and to represent all of this from the original texture, which is here, we essentially generate bitmaps, which just creates a smaller and smaller images of original texture. Sorry for bad drawings, it happens all the time apparently. But anyway, that's the point. This argument here, RGBA, that's, I believe it's the source. So our source has red, green, and blue and alpha channels, and this might be target or vice versa. So, but anyway, we're just going to use full channels here. Onside byte is the usual stuff that you're going to pass, and then we have our image finally that we pass, and that this thing, this guy here, loads our texture. Right? This guy says we're going to use this texture. This says, okay, here is the data, and this is the most important part, image. And then we just generate bitmaps, as I explained bit. We just want to have different sizes. Without this, this might fail. And further, what I wanted to explain is this. Let's just get rid of, where are you? This request animation frame. So if you have a case like this, you don't want this kind of thing to happen in your game, probably. So you can either await all of your resources. Here you can make it asynchronous and then wait, or you can do a simple thing, and that is just to load basically, well, sort of a placeholder texture, right? So what are we going to do? We're going to say text image 2D. Okay, that's fine. 0 is fine. This is fine. Here we're going to have arguments 1, 1. I'm going to get to it. And this is fine. Perfect. It auto-filled everything. So what does this do? Let's comment this thing as well. So this one, again, it has all to do with the bitmaps. So I already explained it. Same as here. This one is same as this one here. This one is same as this one here. This one is same. So the difference is in these two guys, this guy and here. And what does this do? So basically this is just texture width, and this is just texture height. This is the border. 0, we don't need border, I don't care about it. And the final is, so if we have one here, which is width, and this is height, we just created a texture that's essentially 1 pixel. So our texture is just one by 1 pixel, and then this here is just the data that we pass, and this is just RGB color. So if I pass maybe 0 here, it will be black, but if I pass to 5 here, it will be green. Same here, it will be blue. And then we can do maybe combination for magenta. And this way you can just create a placeholder texture until the actual image is loaded. And that's how we essentially do the texture loading. So let's just uncomment this here. And finally, one thing that I missed to explain is why is this upside down? So there is a kind of a legacy reason for that, and that's because the WebGL actually calls a C function, which expects arguments from it expects these pixels to go from maybe better like this, from bottom up, right? And that's why it's reversed, and you can change that globally by just saying this GL pixel store I. Exactly. You can just flip this. You can use this argument, set it to true, and this will flip our textures and have they're loaded, or you can place it to false, then it's upside down. So usually this one is probably good to do, so that you don't get any surprises. And with that said, that's about it. So yeah, we can probably stop here. You can also play with these texture coordinates just to understand how it works. Maybe I can show this. And this will happen because we previously we were mapping from 0 to 1, but since we're actually moving both vertically and horizontally to 2, it had to duplicate this image. So if you, for example, just move vertically but not horizontally, this will happen. Okay, and then you can say 1.5 here, 1.5 here, and then it should just show the lower part of image. All right. So this is how the texturing works. It just takes the coordinates, and with these coordinates you can specify which part of the texture to draw. So it can be maybe I already have some markings here. Let's remove them. It can be maybe 0 to 0 0.5, 0 0.5. It can be maybe from 0 to 1 in y and 0 0.5 in y direction. It can be from 0 0.5 in x to 0 to 1 in x and y direction. So essentially with texture coordinates you can just specify which part of the image to draw, and usually, I mean always, it's from 0 to 1 if you want the whole texture, or you can specify any other number for parts of the texture. And that's how texturing works. So that's it for this video. Code will be on GitHub once again, and for the next video we're going to cover a bit different approach to data loading. So probably we're going to use element array buffer. And what does this do? It allows us, as you can see here, here we have left top again, and same is for right bottom, right? It's duplicated, and in the next video I'm going to show you how can you avoid this duplicated segment. And so thank you very much for watching this, and until next time.